Okay, so now we're back and we're going to go ahead and we are going to continue writing equations. We're going to start with everything in point slope form, so that y minus y1 equals m times x minus x1. And what we're going to do now is we're going to rewrite it so it looks like y equals mx plus b. Just because most people are familiar with the y equals mx plus b form of graphing, so it's always good to have it in that form or be able to turn it into that form so it's easy to graph. So write the equation of a line with the slope of 2 and through the point 0, negative 3. So what we're going to do is we're going to go ahead and put this in the m spot, and we're going to put this in the x and y spot. So it's going to be y minus negative 3. Okay, so y minus our y value of our point, negative 3, equals our slope 2 times x minus the x value of our point, 0. Now to turn this into slope-intercept form, we're first going to go ahead and add a line, change the sign with our double negative. And then we're going to get rid of the parentheses. So I'm going to multiply in this 2. So now it looks like y plus 3 equals 2 times x, and then 2 times 0 becomes 0. And you can write the 0, you don't have to write the 0. And now it's up to us to move that 3 away from the y, so it's just y by itself. So I minus 3 from both sides. And so now we get our final equation, y equals 2x minus 3. Okay, so we'll move on to the next one, doing the same idea. So now we're going to have y minus the y value of our point, 4, equals our slope, negative 2/5, times x minus the x value of our point. So the first thing we do is there's no double negatives, so we go ahead and we distribute that negative 2/5 inside. So now our equation is going to look like y minus 4 equals negative 2/5 times x. And luckily, negative 2/5 times 0 is just 0. I now move that 4 to the other side, so I add 4 on both sides. So now we have our equation y equals negative 2/5 x plus 4. Okay, so now we're going to move to the next one, doing the same sort of thing. So y minus the y value of our point equals slope times x minus the x value of my point. So now we're going to get a little bit more complicated here, because now when I distribute, I'm actually having to multiply that fraction. So when I multiply in by the x, I just get 3/2 x. But when I multiply in by the 2, I am going to multiply 3 times negative 2, and then I'm going to divide by the 2. So this will turn into y minus 7 equals 3/2 x minus, so 3 times 2 gives me 6 over 2. And then I would simplify that 6 over 2. So now this becomes y minus 7 equals 3/2 x, and 6 divided by 2 becomes 3. Now I can move my 7 over. So I add 7 to both sides. So this is y equals 3/2 x plus 4. And there's our equation. Okay, so for our next one, y minus the y value of my point equals my slope times x minus the x value of my point. So first thing, take care of those double negatives. Then I distribute. So now I have y plus 1 equals negative 3 times x, and then negative 3 times negative 8 is positive 24, so be careful of your negatives. And then I move the 1 over to the other side. So y equals negative 3x plus 23. So why do we take the time to write it in slope-intercept form? Well, remember in point-slope form, we had several different equations that were the same equation for the same line. If it's in slope-intercept form, every single person's equation in slope-intercept form will look the same. So for ease of checking answers with other people, with checking answers for the teacher, slope-intercept form is nice because everyone's answer should look the same. Where in point-slope form, everyone's answer can look different depending on how many points we know. Okay, so 2 more examples. This time, we are stepping it up because now we have point-slope form. We're turning it into slope-intercept form, but we also have to take into consideration the slope formula. So now we've got lots of stuff we have to do because now we have to calculate our slope first. Oops, let's not do that. There we go. So now we're going to calculate our slope. So m equals, so we're going to go grab those y's, y2 minus y1 over x2 minus x1. We're going to go ahead and take care of those double negatives. So 2 minus 1 gives me 1. Negative 2 plus 4 is the same thing as 4 minus 2. So there's my slope, 1/2. So now I'm going to pick one point to go ahead and write my equation with. I'm going to go ahead and pick the first point. So I'm going to do y minus my y value equals my slope times x minus my x value. I'm going to take care of those double negatives. And now what I want to do is I want to get rid of those parentheses. So I'm going to do 1/2 times x, 1/2 times 4. So now this looks like y minus 1 equals 1/2 times x is 1/2 x. Now when I do 1/2 times 4, I'm going to do 1 times 4, which is 4, over whatever's at the bottom of the fraction, 2. That was weird. So 2. And now I'm going to go ahead and divide that out. So what is 4 divided by 2? So now it looks like y minus 1 equals 1/2 x. And 4 divided by 2 became 2. Now I can move that 1 over. So y equals 1/2 x plus 3. And that's our answer. Okay, so next step, next problem, same idea. We start with our slope. So I'm going to do y2 minus y1 and then I'm going to do x2 minus x1. Take care of those double negatives. So negative 5 plus 2, or 2 minus 5. 4 minus 5. Let's cancel out the negatives, the double negatives. So we get a slope of 3. Now we get to pick which point we want to use for our equation. I'm going to go ahead and use the second one, just because last time I used the first one. So y minus my y value equals my slope times x minus my x value. Take care of the double negatives. I distribute in to get rid of the parentheses. So now I have y plus 5 equals 3 times x. And then 3 times minus 4 is minus 12. Now I can move that 5 over. So y equals 3x minus 17. And there's our equation. Okay, so we're going to spend some time practicing this. And then we're going to start making it even tougher, because that's what we do. We always push it just a little bit farther. So we'll see you next time.